Hi, this is Austin. This is lab number 2 for kinematics, rotary to linear calculations. So we're going to calculate from serval angle to stroke linear length and reverse as well from the stroke linear length to angle. So we got our spreadsheet over here. This we just should be able to just enter the angle here and it should calculate the distance from the servo, which is L4, this little dotted line, and distance from the bottom of the stroke. It's kind of hard to see on this one. Let's pull this. So distance to the bottom of the stroke would be from this little black distance over here when it's in the retracted state, and distance from top of stroke is from the retracted state end over here, this little dash line, to the extended end of the rod over here. So this black little line over here, this arrow. So first things first, we'll go briefly over the calculations. So this is the reference equations we use to calculate, and we input these equations into Microsoft Excel, and that's how we're able to pop out these values over here. And there's L4 right there. Okay, so a weird thing with this setup is that there is a little offset distance, this little orange box over here, that at the end of the orange box is our technical 0 point. So the offset distance from the blue end of the blue thing over here, as you can see in the picture, to the end of the rod when the rod is at 180 degrees. That distance is this little orange block, which is 16.50. So we will reset it right now to 180 degrees. That way you can see the offset distance. Okay, so it's a little bit hard to see. Let me increase the resolution here. So as you can see, this is at the 180 degree position, and the end of the rod over here is at this 0 mark over here. Be careful though, these little grid squares, they're not a centimeter. They're actually like, I think around 12 centimeters, or sorry, millimeters. Yeah, about 12. So two of these will equal 1 inch way down here. See the 12 to 13, that's an inch. But we're just using this 0 point as a little reference mark. Okay. All right, so now that we showed you the offset distance, we will put it to 60 degrees and input it in our spreadsheet over here just to see if our calculations match real life measurements. So we're going to move it to this little line right here. This is 60 degrees. And then we're going to measure. All right, roughly there. Let's make sure it's aligned again. I have a little black Sharpie mark over here for alignment. All right, so it's at 60 degrees. And now we're going to measure from, get a little cool pointer. We're going to measure from the 0 here to the end of the rod. So the end of the rod is roughly right about there. Let's, fuck it, we'll do a little Sharpie. Sorry for cussing. Okay, All right, so we're gonna measure from 0 to this little Sharpie mark over here, and then we'll compare it with our calculations. Yeah, pretty spot on. About 44, 45-ish millimeters. Let's see. All right, so yep, at 60 degrees over here, as you can see. We earlier we measured the whole thing plus the offset distance, so we subtracted it, but it comes out to, yeah, roughly about 44.01 millimeters. This yellow box over here, distance from the servo, we can double check that as well. I'd say it's pretty close. Maybe 100, 194, 193, somewhere around there. I think our eyeballing calculations were off before. So as you can see, the in the retracted positions, our measurements match up. Let's input it into the spreadsheet here. So we got 60 degrees over here. Distance from servo 191, plus or minus a couple millimeters. Distance from bottom of stroke, that is the distance should be about 43. Yeah, we measured that earlier actually. We're close to 45-ish. And now we need this distance from the top of the stroke in real life. So we are gonna pull it to the, hang on, let me shrink this thing. We're gonna pull it to the extended position over here with the arm fully extended, and then we will get this black distance over here. Okay, so let's do that. All right, let's extend it all the way to this mark right here, 0 degrees. There we go. All right, and just to double check this purple value, which is from the edge of the blue frame to the end of the rod when it's extended, it should come out. Yeah, it should come out pretty close. I'm about 80, maybe 87, 86-ish, plus or minus a millimeter or two. So that matches our calculations. And then we will get the current position in extended over here, wherever the rods ended at. It's just roughly right about there. So this is, we'll put E for extended, R for retracted. All right, and if we measure the difference, we should get pretty close to our black value over here. It's 26.18. Yeah, we get about 24, 25-ish millimeters, plus or minus. So going back to our spreadsheet, distance from top of stroke, it's pretty darn close, 26, 26. All right, and let's see. Next, we'll go with distance to angle. Okay, next we're going to do length from servo to servo angle. So right now the servo angle should be at 180 degrees over here. And then we're going to measure the length from servo to the end of the rod over here. All right, so we're sitting at about 148-ish millimeters. We're going to enter that into length of servo. And pops out with 180 degrees. Okay, and then let's jog it down to this mark over here. So each tick should be 30. 180 plus 60 is 240 degrees. So that's our calculations, and we'll input it in here. Okay. All right, so now we should be at 240 degrees. Let's measure. We're sitting about 160, 159-ish. Okay, so 159. And we are popping out with 112. That doesn't seem right, probably because with the quadrant. Oh, I think it might be taking from this 0 point over here. Here, let me move this shit up. I think it's taking from this 0 point over here, and it's going 3, 6, 7, 9, 10, 11, 12. It's going this way. That's why it's popping out 112 degrees. So that is definitely a fault. We could probably fix that with some trig functions. Might have to look into that in the future. But yeah, we'll stop here for now, and I'll call it good.